So number 49, we have a 100-watt light bulb that's plugged into a standard 120-volt outlet. Question A, how much does it cost per 31-day month to leave the light turned on continuously? Assume electrical energy costs 6 cents per kilowatt hour. So solving this one, quick reminder, energy is equal to power times time. That's just rearranging the power equation. In this case, the energy is going to be the power usage. Now 100 watts converted into kilowatts, since we need kilowatt hours, our 100 watts is going to be converted into 0.1 kilowatts. And the time we need in hours. So we know there's 24 hours per day. In this case, they tell us it's a 31-day month. So we're going to multiply by 31 days per month. If we do that, we'll discover that the total energy use is 81.3 kilowatt hours. Multiplying that by the cost, which is 6 cents per kilowatt hour, we'll discover that light bulb is going to cost $4.90 to run for the entire month. Question B asks, what's the resistance of the bulb? Now, there's a couple ways you could do this. I'm going to probably do the simplest way. If you remember, one of our electrical power equations is voltage squared over resistance. Don't get confused with centripetal force, which is velocity squared over radius. In this case, just plugging in our numbers, our voltage 120, our power 100 watts. Solving for the resistance, you'll discover that's about 144 ohms. Finally, for part C, what's the current in the bulb? I think actually this one's the easiest. I'm going to go back to the very basic definition of electrical power, which is current times voltage. In this case, we know the power is it's a 100-watt bulb. The voltage is 120 volts. Solving for the current then, we'll get the current is about 0.833 amps. Kind of like this problem. It's interesting. It's a 2-star problem. I think A is the hardest. Rest of it's not too bad. Enjoy.